Okay. Good evening. Today we are going to discuss lecture number lecture number lecture number 44, which is the topic is hunting hunting of synchronous motor. Hunting of synchronous motor. So the meaning of hunting means when you know the structure of synchronous motor, right? This is the stator. This is the stator. Inside there will be the rotor. This is the rotor. Okay. And here the center portion there will be the winding. Okay. So in this winding only you are going to give DC plus minus DC excitation. You have to give DC excitation. Okay. And where we are going to give the AC supply. The AC supply which we are going to give a three-phase AC supply which we are giving in armature. Okay, three-phase AC supply, and the stator means armature. Okay, so the meaning of hunting when the synchronous motor when the synchronous motor is is used for driving driving a varying load. Varying load means a different loads. Varying load. Okay. Then the condition then the condition is known as hunting. HUNTING. Okay. The second point, this hunting may also be caused if supply frequency which we are giving in AC supply 50 hertz. Okay, if supply frequency is pulsating. Pulsating means, the meaning of pulsating means instead of 50 there will be 51 or 49 or 52, like that. Okay, there will be a large number of distortions are there in the frequency. That is known as pulsating. And this pulsating which is applicable in case of generators, which will be connected in terms of an engines. Maybe it will be called internal combustion engines, which will be connected in the power plants. Okay, it will be connected in the power plants. Okay, so due to the supply frequency pulsating, okay, due to variation in the supply frequency Fs, the hunting also be caused. Okay, now we are going to discuss how this hunting will be happen in no load and loaded case. Okay, suppose when a synchronous motor, okay, SY stands for synchronous motor, is loaded. Okay, now the synchronous motor is loaded. Okay. Loaded means here I can connect the synchronous motor with a compressor or pump. Okay, or pump applications or pump. Okay, when it connected in this, what happened? The rotor falls back in phase by coupling angle alpha, in phase by coupling angle alpha. In some textbooks they will use a notation called a del, also they can use. Okay, so this type of del they can use it. So whichever the book which I am referring, it will be angle alpha. Okay, now this alpha, okay, now what happened, as a load, okay, as a load is progressively progressively increased. Okay, if the load will be keeps on increased, then then the then angle alpha also increases. Okay, then the alpha also increases. Due to this increase in load as well as alpha, then there will be more torque is present. Okay, there will be more torque will be present. Okay, that fourth point will be, suppose if there is a sudden decrease in motor load. Okay, because now the machine is start running it, now you are suddenly decreasing the motor load. Okay, decrease the motor load. So during that time, the motor, that is our synchronous motor is immediately pulled up. Okay, immediately pulled up to a new angle alpha. Okay, new angle alpha. So because of this, okay, so because of this angle alpha, what happened, the rotor is overshoot. The rotor is overshoot. The rotor is overshoot, and the rotor starts oscillating. Okay, rotor starts oscillating. Because of this oscillation, because oscillating means it is like the movement of it's like a pendulum. Okay, it is like a pendulum. Oscillating means it is like a pendulum, it is oscillating. So because of this oscillating, there will be a new position. Okay, there will be new position of equilibrium. Okay, equilibrium value corresponding to new load, okay, corresponding to new load. I will show this waveform how this oscillation will be there. Okay, you please listen. X-axis will be time, okay. Y-axis will be load angle alpha or coupling angle alpha. Load angle alpha. This is my maximum point. Maximum point. It is. I already mentioned it will be alpha, or we can use del also. Okay, I can use the maximum angle of alpha. This is. This one will be a alpha value. Okay. Now this angle. Okay, the waveform of this angle, how it will be? It should be, because we know that the waveform will be a sinusoidal waveform, because a back EMF waveform will be a sinusoidal in nature. So it should be like this. Okay, starting it will be going very smoothly, then it is based upon the movement of the rotor, it starts oscillating like this. Okay, this is the oscillation. Okay, sometime we are getting the oscillation, it will be like this also. Okay, it will be like this also, but anyway it should be a sinusoidal in nature. So this position is known as new equilibrium position. Okay, a new equilibrium position. Okay, so you see this waveform. Actually this waveform will be a normal waveform, and this waveform will be a, when the machine will be starts. Okay, that is when the machine will be, if you decrease the load, there will be a sudden disturbances in this wave. Okay, so this type of the point which we are saying, it will be called, which will be called a settling time, which will be called settling time. Okay, you see this red color, the waveform is too lengthy, because we are not having only armature winding, another one is field winding is available in the rotor. I am not introduced any additional winding there, because I have to avoid this oscillation. I have to control this oscillation. So how to control this oscillation? To control the oscillation, to control oscillation. So in the structure itself, in the stator winding structure itself, we have to introduce damper winding. Okay, this damper winding which will minimize the oscillation, So you see the second waveform, because of I have introduced this damper winding, the oscillation point will be stopped here itself. Okay, so this green color line stands for damper winding arrangement, because we are introducing the damper winding arrangement in the stator to minimize that oscillation. Okay, so the time ends, the waveform which will be ends in the time point, that is nothing but a settling point which is due to damper winding, arrangement. And what happened without damper winding? What happened? This overall time period which we are marking here, this is the settling time, or or hunting period. Okay, or hunting period without a damper winding, okay, without damper winding structure. So to minimize this red color line, I am introducing the damper winding in the stator. Stator means armature winding. We are adding a additional winding, that is nothing but damper winding. So where is damper winding which is applicable? In the mechanical parts which is applicable. Okay, in the mechanical parts will be applicable. Okay, now What are the causes of damper winding? Okay, causes. This is 2 mark question. Causes of hunting. Okay, the hunting will be caused due to sudden change in load. Okay, that is the first point. How the hunting will be caused? Due to sudden change in load. This is my first point. Sudden change in load. Second point, sudden change in field current. Next point is sudden change in field current, IF. Third point, a load containing harmonics in torque, containing harmonic torque. Fourth, fault in supply system. Okay, instead of three phase, in three phase the balanced line you are giving 400 volt 400 400. Instead of 400 400 400 you are giving R line will be 230, Y line will be 400, B line will be 400, so the R line will be unbalanced. So fault in supply system. Okay, these are the causes of hunting. Okay, and what are the effects of hunting? Effects of hunting. First point, it may lead to loss of synchronism. Okay, the first point will be it may lead to loss of synchronism. Second, there will be a produces mechanical stress. Okay, mechanical stress means where it will happen. It is happening in shaft. Mechanical stress in rotor shaft. In rotor shaft. Third, which increases machine losses, which increases machine losses. Fourth, if the losses are increased due to hunting, then there will be increase in temperature. Increase in temperature. Increase in temperature. Fifth point, which will increase the resonance also. Which will increase resonance. Resonance which will be happening in winding arrangements. Resonance. Okay. Now, how to minimize or how to eliminate this hunting or how to avoid this hunting? The first method, we have to introduce the damper winding arrangement. Okay, because the damper winding which will be made up of copper or aluminum material. Okay, copper or aluminum material, so which will minimize this hunting methods. The second one, you can implement a flywheel arrangement. Okay, the first one will be a damper winding to control this hunting. The second one will be you can use the flywheel arrangement. Flywheel arrangement you can connect it with the prime mover. Okay, to maintain the rotor speed constant. Third one, in design aspect itself, we have to, in design, we should be very concentrated on design with a suitable synchronizing power coefficients value which we have to implement. Okay, so to minimize hunting, there are three methods are there. The first method will be damper winding, second method will be flywheel, and the third method will be design. Okay, third method will be design. Any doubts in hunting? Any doubts in hunting? Now, now we will solve one problem. Okay, so this is the problem. See here, is the problem. Consider a 3300 volt delta connected synchronous motor having a synchronous reactance per phase 18 ohms. It operates at a leading power factor of 0.707 when drawing 800 kilovolt watt from mains. Calculate its excitation EMF and rotor angle. Okay, first solution. Solution. The first step, please listen carefully. The machine will be, the machine is delta connected. Okay, please take down. This is delta connected. Okay, you already know in delta connected, the V line equal to V phase. The line voltage is equal to V phase, but I line equal to root 3 into I phase. Okay, this is a formula. Okay, this formula only now I am going to use it. Okay, so what is my line voltage? Because whatever the value which is represented in the problem, it is line values. Okay, V line equal to 3300 volt. 3300 volt. This is V line, which is equal to V phase. Which is equal to V phase. Next one, line current. Whether line current is available? No, because we have to calculate the line current. So how to calculate the line current? Okay, the general formula, power equal to root 3 into V line into IA into cos phi. Okay, so this P is already given. The overall rating will be 800 kilowatts. So 800 into 10 power 3, which is equal to root 3 into line value. How much your line? It is 3300. Substitute. Into IA. IA is nothing but your armature current. IA into cos phi. Cos phi you see here, it is 0.707. That is perfect. So can anyone tell me how much IA value? IA, what is the answer? IA I got, it is line current 198 ampere, because IA is nothing but line current. IA is nothing but line current. Armature current is nothing, because line current you are giving in only in armature. Armature is nothing but stator. So IA equal to I line current. Therefore, since the machine is delta connected, okay, so the phase current IA phase equal to 198 198 divided by root 3. You will get 114.3 ampere. 114.3 ampere. Okay. Now we will write the formula. What they are asking? It will be excitation EMF. Since the machine is leading power factor, it is leading power factor. The formula which you already familiar of the formula, EB equal to square root of V phase square plus ER phase square minus 2 into V phase ER phase into cos of theta plus phi. Okay, see here, theta plus phi. Okay, this plus symbol which is applicable for leading power factor. Okay, if it will be plus means it is applicable for leading. Okay, minus means lagging. Okay, in your question itself they mentioned clearly, they mentioned it is a leading power factor. That's what I have written, cos of theta plus phi. Okay, now we will find each and every value. V phase you already know, square root of V phase. What is our V phase which is there? 3300 whole square plus ER phase you don't know. Okay, ER phase you don't know. So how to find ER phase? ER phase formula. How to find ER phase? It will be IA into ZS. IA into ZS. Okay, so IA into ZS. How to find a ZS? ZS it is given. Okay, so I can directly do IA value. How much IA value? 114.3. Substitute 114.3 into impedance. ZS will be a synchronous impedance. It's given. Okay, synchronous reactance per phase will be 18 ohms. 18 ohms into 18. So you can get 2058 volt. Okay, 2058.
Reactance no.
What?
Reactance means excess no.
ZS is equal to XS. Okay, here the machine, because we know the formula Z equal to R plus JXS. Okay, R plus JXS. Since the machine is operating in delta connected, this R term will be very small. Okay, in delta connected the resistance value will be very small compared to reactance, so this R term will be neglected. Okay, that's why they are not given this specification in your question itself. Okay, the R term will be very much smaller compared to reactance, since the machine will be operating at leading power factor. In leading power factor the resistance term will be very small compared to reactance, so they have given we have to take R to be eliminated, so we have to take ZS is equal to XS. Okay, that's what I have substituted directly here. Are you understand? Are you understand?
Yes sir.
Okay, so now substitute here. XS value, XS will be a synchronous reactance which is already given in your question. Okay, 18 ohms which is they already given. That value have substituted 2058. Now you got the answer 2058. Now you substitute here 2058 whole square. Okay, then minus 2 into, you put a common bracket, 2 into V phase 3300 into ER phase 2058 into cos theta. What is theta? Theta, how to calculate this theta value? Anyone? Theta. Okay. Phi value how much, ma? Phi is how much? In your question, the power factor they have given, right? They have given power factor is 0.707. That is cos phi equal to 0.707. So from this, phi equal to cos inverse of 0.707. How much it comes around? Cos inverse of, anyone, can you please give me the answer? Cos inverse of 0.707, it comes around a 45 degree. Okay, 45 degree. This value I have to add. Cos plus phi is 45 degree. Now how to calculate this theta? Theta value, how to calculate this theta, anyone? Anyone? The theta value will be, it should be 90 degree. Okay, it should be a 90 degree. Okay, how I draw this 90 degree means, this is the terminal voltage V phase. Okay, see, and since it is leading it, this is my IA. Okay, this is IA. This one only we have measured 45 degree. Okay. Now in leading power factors, the ER phase, the resultant ER phase, it will be look like this. Okay, this is my point. This angle from IA, it should be 90 degree. This value which I have written, this is ER phase. The angle between ER phase and IA should be 90 degrees. So in your examination, if I give this problem in your examination, whether it will be CIE 3 or otherwise in semester, you have to take the angle between IA to ER phase should be 90 degree, because this 90 degree which is not mentioned in your question. Okay, this one will be a indirect problem. You have to consider 90 degree. Okay, you have to consider this 90 degree. So better I can note down here, please note down here, consider theta equal to 90 degree. So where is the theta? Theta will be an angle between ER phase and IA. Okay, that's what I written. Now find the answer. The final answer, can you please tell me, anyone? What is my final answer? Anyone? Anyone? Please give me the answer, ma. Final answer. It comes around 4973 volt. This is EP. Okay. So now I have to join this line. This line will be called as 4973 volt, and this line 0 to ER phase line will be, it will be 2058 volt. Okay, the line of 0 to V phase will be 3300 volt. 3300 volt. Okay, now how to find alpha? What is my alpha? How to find? This one I can mark it as 0 a b. I can mark the terminal 0 a b. So from it will be look like a triangle. Okay, from triangle o a b we can get sine alpha. Okay, sine means you peoples are already familiar. What is sine term? Sine alpha. What is the formula? It should be by opposite by hypothesis, right? Opposite will be, the opposite side will be 2058 divided by hypothesis, it is 4973. Okay, 4973. So how much it comes around? Anyone? So 2058 divided by 4973, it is 0.413. Yeah, it is alpha equal to 24 degree. Alpha equal to 24 degree. We can measure. Okay. Any doubts?